Right, which exercise
yes,
is
I can get it
this?
for you in a moment. I've got your test as well. Yeah. So I'll just go through this. This is going to take probably 2 minutes. This will probably be one of our shortest. So, guys, we've had a couple absences, we've had a couple interruptions. I was away, then half the class was away. So, what I'm going to go through at the start of the lesson today is 4E.2. Now, there's 2 questions in this, and it really follows on from 4E.1. And so what I'd like to do is I'd like to start with this, maybe spend 10 minutes doing this, and what I'm really looking for is affirmation from people that they understand how to do 4E. Okay, I'm not really concerned about B, I'm not really concerned about D. Both B and D are sort of preliminary steps to integration. What they're doing is they're introducing you to the idea that it's just backwards differentiation. That's their purpose. Alright? So I understand we may have found it challenging, but once we learn the rules in E, if you were to go back and do B and D, you'd be like absolute cheese. So maybe you found it hard, maybe you've got questions about it. Let's leave them aside for now. I'm hoping that people have sort of done 4E. That's what I'd asked. And so what I'd like to do today is 4E2. We'll smash that, and then even have a look at 4F. Okay, both are just applying rules. So in 4E2, let's do our example here. We're just going to be using this formula. We've got some derivative function. We're told here's f dash of x. The question says find f of x. Alright, so the relationship is if this is the derivative, then we need to find the integral of this with regards to x. Now before we can integrate, we need to express everything, like in calculus, as x to the power of n. That's already done for us. We've got everything as x to the power of n. Now I'm gonna break this one up into a series of steps just to show you guys exactly what's going on. What we're doing, just like differentiation, is we're integrating term by term. So that means we're doing the integral of x to the 3 plus the integral of 7x, and then take the integral of 2, all with regards to x. Okay. And then even one way you can think about it is it's the integral of x to the 3 plus the 7 times the integral of x. Alright, so if there's a number, that can just come out the front of the integral. Just like differentiation, when we differentiate, the number just hangs out there. And then we have take the integral of 2. Okay, so all these steps are completely unnecessary. Alright, so when you're doing a problem, you can go straight from here to our answer, which we're going to do now. And we're just applying this formula. If we have x, the integral of x to the n is x to the n plus 1 on n plus 1. So if we've got x to the 3, we're going to have x to the 4 on 4, okay, plus 7 times the integral of x. X by itself is x to the 1, so it's going to be x squared on 2. And then the integral of k, or any number, is going to be kx. So the integral of 2 is going to be 2x. And then we have plus c. We always put plus c when we have completed integrating. Okay, so that would be our f of x, right? But it wants us to find it exactly. So the extension part here on 7E2 is that you're finding this value of c. All right, and you're always going to be given some more information to find c. This new piece of information tells us when you put x is 0 into this equation, it's going to equal minus 3. Okay, so f of 0 equals minus 3. Well, f of 0 is going to be 0 plus 0, take 0, plus c, isn't it? All of that's just going to 0. And so what we've got is we've got c is minus 3. And so therefore, f of x is x to the 4 on 4, plus 7 on 2x squared, take 2x, take 3. Okay, so that's what we're up to today, 7E2. So I'd like us to give that a go, and if I could collect some stuff for people and come around and see how you're doing.